And hello everyone, welcome back to another Golang tutorial. So, in the previous tutorial, we looked at arrays. If you have not yet seen that tutorial, I do recommend you do, because this tutorial will be building off of that tutorial. So, a slice is very much like an array. So as you know, if I were to say friends, and here I could do something like free string, and then I can just specify my friends, and then I have my array. I could also, if I want to remove the limit on how many items is allowed in this array, so that I don't have to specify the number here, I can do ... and now I can have as many items in here as I want. However, you'll notice if we go friends and then specify an index that does not exist here, and we make that equal to Mike, like with lowercase, or let's actually go Kale, and then I print out friends, then if I try to run this, you'll notice I get an error. That is because whilst this array right here, we don't need to specify the number. We cannot add anything to it afterwards. We can modify what is inside of it, but we cannot make it any longer. So this right here, even though we didn't have to mention that it is free long, we can just put a bunch of dots here. It will still see this as free items long. And then once we try and add in fourth item, or even if we just set index free, it won't be able to add that item because it is locked at that size. This is where a slice can become very handy. We can remove this limitation by doing this. This is no longer an array, but a slice. It has no size limit. So if we were to try and display this, we'll get a normal thing that looks just like an array, because it basically is. However, we can now go friends is equal to append, and then it automatically actually filled out friends for us. And now we can add more things here. So here we can say, there we go. So now we append Luke and John. Now if we were to run this, you'll notice we now have 2 extra items on here. And for those who might be wondering, if we were to add ... here, and then try to run it, you'll notice it still won't work. That is because slices and arrays work differently. So take note, this is a slice, this is an array. And right here, we can add more items to it. And just like with an array, we can specify a specific index and then get that item at that index. We can also get the length of a slice, just like with an array. And that should be len, not length. And then we get the length. As you see, it's 5. And if we were to do this, then it will increase. So 5 and then 7. Now there are more things you can do. For example, let's just remove this ling here. We can also go like this, and then this. So we are now adding a slice here. So let's actually do something cooler. Let's move this here and say more friends. And more friends is a slice of course of type string, like that. Now here we can say more friends ... Oh, there we go. It already filled it for us. So now more friends and then 3 dots, where it will basically spread these into 2 items. Now if we run this, there you go. We have the same thing, but now we can add another slice into this slice right here. Now just like with arrays, if we wanted to go and change a specific item, we can. So if we go here we can make that equal to whatnot. And if you run that, then as you can see, it changed. So you can use this to modify it. Now, let's quickly build ourselves an array. I'll call this X because why not? And X is an array of 2 items. Let's go int. And here we just store 6 and 7. Or let's go 6 and 100. Now, if we were to say that Y becomes X, then we can, of course, print them out. So print out X and then as well print out Y. And let's just quickly comment this out. Now, if we were to run this, then we'll get 6 and 100. So this Y can copy this X. Now, if we were to go here and say Y, and then let's say at index 1, make that equal to 96. Then if we run this, you'll notice that X stays the same and Y changes. So Y now has 96, but X does not. This is how it works with arrays. However, with something like a slice, it is a bit different. If we go here and say X becomes friends, whoa, then of course we can display both friends and X, and it'll get the same values. But now if we were to say X at index 1 becomes, and just some random text, or not becomes, is equal to, there we go, and we run this, you'll notice that both of them change. This means X is referencing friends, but basically X has actually become friends. That's a very big difference between slices and arrays. With slices, you will modify the original slice if you modify its copy. But with arrays, you'll modify the new array, not the original. So just be careful here. So with slices, this slice will modify the original. Very important to take note of. Next, I want to show you a few ways you can also get items from a slice. For example, if you were to do this, then this will print out all of the items inside of that slice. So if you know Python, you'll know how this works here. So you can see Nick, Jack, Mike. You can also copy a slice with it. So if I were to say X becomes friends like that, it will be exactly the same as if I were to have said this. So these two are the same basically. Now the nice thing about this is, let's just maybe change this to an integer and then add a few items. 1, 2, 3, 4, 5, 6, 7, 8. And just so things don't get confusing, let's actually make it start at 0. So every index is now the same as the number. So index 0 is the value 0. Index 1 is the value 1. And if we run this, this will work perfectly fine. But if we were to say 2 colon, then now it will go and copy everything from this index. So index 2 all the way up. So index 0 and index 1 will get removed. And then the rest will be copied. You can also specify from behind. So let's say 4. Now if we do that, then everything up until but not including index 4 will be copied. So everything up until, so 1, 2, 3 and 0, but not including 4 itself. You can also merge those two together. So if we say 2 and 4, then now we'll get 2 and 3. Because it includes 2 and copies 3, but does not include the last, this index here. So it includes index 2, but not index 4. And if you're getting confused, you can also remove that 0 and see it work like this. I just basically added that 0 in order for us to get the same index for the same item, but you can remove it, then you'll notice that the indexes is what matters and not the numbers themselves. Now you will notice if I were to try and remove this part here and just declare a slice just like that, it will cause a little bit of a problem because we cannot just declare a slice like this. What we will have to do is we will have to say make, because we're not actually telling it what the size of the slice will be. So modifying it later will cause a lot of problems for us. But if we do this, then we can say that this slice will have 3 items in them, but it can store up until 100 items. So we're telling Go, create a slice for us. The first 3 items in the slice has to be there, it's mandatory. But the slice itself can also have up until 100 items inside of it. What is basically happening is it is creating a slice with 3 zeros inside of it. Because we're saying we want at least 3 items in it, but it can go up until 100. So 3 items will be entered for us. You can of course also check the length of this slice. And you can also check the capacity of the slice. So as you can see, the length itself is 3, but the capacity is 100. Now, note that this capacity will not force it to be this size. If you set the capacity to something like 4, and you were to append things here, so friends is equal to append, and let's say 6543, and you were to run this, it will go without a problem. This right here is just to give yourself an initial knowledge of what the capacity could be. In fact, if you wanted to, you don't even need to specify the capacity. Now some of you might be thinking, this is all cool and whatnot, but what if I want to just delete items inside of it? Well, you can. Let's put some random numbers in here. There we go. If we were to print that, we can. And let's just rename this to X to make it a less of a typing experience. Now down here, we can say X is equal to itself. And let's say we want to remove the first element in the slice. We can then say 1 colon. So this will copy everything from index 1, not index 0, but index 1 and onwards. If we were to run this now, you can see we don't have 4, but we have 5 at the first index here. Now, if you wanted to, you could specify E and then say colon X, let's say 1 colon. And in here, you could just print out. Now, you might think this will modify the original as well. However, you'd be surprised if I were to show you this. So X will stay the same, but E will now not look the same as X. But you should be careful here. You might think they're now 2 different items, but they're still very much referring to the same item. If I were to go here and say E at index 2 becomes, or just equals, doesn't have to be become, and I can just go put a bunch of 2's here, and I run this, you'll notice it affects both of these. So just because we are modifying E, which doesn't look the same as X, it will still modify the original items in X. So just be very careful with this. So I'm going to go back to just modifying X itself. And here we can say is equal to. And then of course, if you want to remove the last element inside of a slice, you can just say len the slice minus 1. And this will remove the last item inside of the slice. Why? Well, because we're saying the length, and I don't know how long is this, it doesn't really say, but it's the length, and let's say this is 5, I'm not going to count it, it's actually 7. So 7 minus 1, and that will give you 6. So 0, 1, 2, 3, 4, 5, 6. And we know this doesn't include the last item, or the item in here. So if we pass in 6, which is going to be passed in thanks to this, then it's not going to include 6. It's going to include everything else before it, but not 6. So if we run this, you'll notice the last element is gone. If you want to remove an element from the middle of the slice, it's a bit more complex. So we can just say x is equal to append x, and in here we can specify x, and let's say everything up until 2, and then x for colon dot dot dot. And we do not specify that x there specifically. Now if we run this, you'll notice we have 4, 5, 65, 123, and then 3. So unlike the original, which is 4, 5, 62, 34, and then 65, 123, and then 3, we removed these two. So here we're saying x, and then everything up until, but not including index 2. So 0, 1, and not including index 2. So just 4 and 5. Then we're saying x, everything from index 4 and upwards. So from here, it's index 0, 1. Then we're skipping 2 and 3. And then we're first starting again at 4, 5, 6, as you can see. And that is how you can remove elements from the middle of a slice. And that is the basics of slices. Thank you all for watching. I hope you all enjoyed and that you can all now work with slices in Go. And I'll see you all again in the next Golang tutorial.